Okay, so I'm going to work through one more example, and just to mix things up, I'm going to write this with the chevron notation. You'll notice the previous example we did, everything worked out to be a nice, neat little whole number. Well, that's not going to be the case typically, and so I'm just going to pick some numbers at random. I'm going to say this is -2, 3, and let's go 5, 1. So I'm just picking two vectors out of the blue sky, and we'll see what we get out of all this. So I want the projection of V onto W. So the form is the dot product divided by the norm of W squared times vector W. Again, the only place this first vector appears in this formula is in the first item you write down. The first vector you write is the first vector. Everything else is the second vector. So, now square root squared, well, I'll go ahead and write that in, times vector W. Well, vector W we know is 5, 1 in chevron form. So this is the dot product, so its first components multiplied, -2 times 5, second component's negative multiplied 3 times 1, and then we need vector W's magnitude. So this is 5 squared plus 1 squared. And out of all that mess, we're going to create this projection. So this is -10 plus 3 over square root squared cancels. And so this is 25 plus 1 times vector 5, 1. And so what does that become? That becomes -7 over 26 times vector 5, 1. You may leave this out front. In some circumstances that's more convenient, but what we're going to do is multiply that in. It's multiply top times top, bottom times bottom. So when you do the scalar multiplication here, I'm going to rewrite this, -7 over 26 times vector 5, 1. That's -35 over 26, comma, -7 over 26. So, typically, if you just randomly select two vectors, the projection vector is not going to be something nice and neat and tidy, but the computation is straightforward.